In this video, we're going to be looking at Unit 6 test. This one's specifically version A. So if you got version A, you got the same numbers. If you got a different version, numbers will be slightly different, but the questions are all basically the same. What I have with me to help me out I have the periodic table. It's going to have all my molar masses here right below the elements. And because of my conversions, I got my mole roadmap to help me with my conversions from moles to particles and moles to mass. Question one, it starts off with a tough one. Which of the following does not belong? It's going to be which of the following is a different amount of particles. So we're going to actually come back to this one after we do the rest of the 9, because it's kind of a tricky one. And it takes all the skills from these other questions. So for question 2, how many particles are in 1 mole? 1 mole, the definition is 6.02 times 10 to the 23rd particles, and that's just a definition. That number's on the board at all times, so you could just look up on the board if you forget. Find the molar mass of lithium. So molar mass, we got our periodic table. You got to find lithium. And the molar mass is how much 1 mole of this weighs. So 6.941, we're going to round that to the nearest whole number here. 7 grams per mole. What that means is if I have 1 mole of lithium, it's going to weigh 7 grams. If I wanted to find the molar mass of a molecule, you have to add up the mass of every atom in the molecule. So what I like to do is I like to write it out like this. We got 2 different elements, carbon, we have 2 of them, and we have 6 hydrogen. And we have to look up the mass of carbon. Carbon, looking here, has a molar mass of about 12 grams per mole. So 2 times 12 grams per mole is about 24 grams. And hydrogen, the smallest element right here, about 1. So 6 hydrogen will weigh about 6, and you add these together for a molar mass of about 30 grams per mole, meaning 1 mole weighs 30 grams. So now I would take that molar mass and it could help me answer questions 5 and 6. So question 5 says, how many grams are in 4.5 moles of C2H6? Well, I know if I have 1 mole, it's going to be 30 grams. So if I have 4.5 moles, it's going to weigh 4.5 times as much. So we're going to write 4.5 moles here of C2H6, and we multiply it by the 30 grams per 1 mole, and we got our calculator right here. 4.5 times 30 gives us about 135 grams of C2H6. Similarly, I could ask a question here where it says, how many moles are in 12 grams of C2H6? And right away in my head, I should be thinking, is that more or less than a mole? And because I need 30 grams to have 1 mole, 12 grams are going to be less than a mole. And the way we want to show our work here for this one is be 12 grams C2H6. And it's a division problem. 1 mole is 30 grams. And it would be 12 times 1 divided by 30, or just 12 divided by 30. Plug that in the calculator. And you get 0.4 moles. C2H6. Question 7, find the molar mass of carbon dioxide. So very, very similar to question 4 up here. We got 1 carbon, we got 2 oxygen, and we already said, 1 carbon weighs 12 grams. And oxygen, we have 2 of them. 15.999, that's basically 16 grams. So if 1 oxygen weighs 16 grams, 2 oxygen would weigh 32 grams, and the whole molar mass of carbon dioxide would add both these together, 44 grams per mole. Meaning if you had 44 grams, you'd have 1 mole of carbon dioxide. For the next question, how many molecules of carbon dioxide are in 22 grams of carbon dioxide? So we're going from grams to molecules. And this is why, we got our roadmap here. If I want to go from grams to molecules, it's 2 steps here. So I have to divide by my molar mass to get moles, and then I need to multiply by Avogadro's number. So let's do that first step first, 22 grams, and we'll find how many moles it is. 22 grams of carbon dioxide. And we know 1 mole weighs 44 grams. So I want you to be doing that estimation in your head. Is this going to be more or less than 1 mole? Always think that. 22 is less than 44, so it's going to be less than a mole. So when we get our answer, we should be expecting a number less than 1. 22 divided by 44, 0.5. So it's 0.5 moles CO2. And now I have just 1 step here, 0.5 moles. To go from moles to molecules, I just multiply by Avogadro's number, because that's what 1 mole is. So I'll take my 0.5 times, now take a look at how I plug in Avogadro's number here. It's 6.02 exp right here, the exponent, 23. And that's going to be my answer. It is going to be 3.01 times 10. And here's something you got to be really careful with. There's a little tiny times 10 there to the 23rd. So you want to make sure you write that times 10 to the 23rd. Molecules of CO2. All right, and question 9 is the exact opposite. How many grams are in 1.2 times 10 to the 24 molecules? So what we have to do is we are going now from particles to moles. So we've got to divide by Avogadro's number, and then we have to multiply by the molar mass. So let's jump right into that here. 1.2 times 10 to the 24 molecules of CO2. And we got to get moles, and we know 1 mole is equal to 6.02 times 10 to the 23rd. And let me show you what it looks like in the calculator, because even though I'm multiplying here, or I should say I'm dividing, but even though it looks like there's multiplication signs here, I never have to push multiply. So it's going to be 1.2 exponent 24 divided by Avogadro's number, 6.02 exponent 23, and it's going to be up 1.99. That's basically 2. If you put 1.99, I'll take that as okay as well. So it's about 2 moles CO2, and what I want us thinking at this step is, I got 2 moles of carbon dioxide. Remember, 1 mole weighs 44 grams. Would I expect my answer to be more or less than 44? And if you said more, you're correct. because we got more than a mole. And 2 times 44 is about 88 grams of CO2. All right, so now we've done some conversion. Conversion is probably the most important thing to take away from this unit. So if we're feeling good about this, we should be feeling ready for the next unit. Back up to number 1. Which of these does not belong? Which one's a different number of particles? I'm going to convert them all to moles to help me. So 1 mole of CH4. If I look at this number right here, 6.02 times 10 to the 23rd molecules of carbon dioxide, that's also 1 mole. So A is a mole, C is a mole. Now I'm going to look at B and D and think which one of those is a mole. Well, we said, 44 grams of carbon dioxide. Remember, that was the molar mass, meaning that 1 mole weighs 44 grams. So this is 1 mole as well. So A is a mole, C is a mole, D is a mole. If we worked out 32 grams of water, turns out that water has a molar mass of 18 grams of water for every mole. So this is going to be a little bit more than a mole. So this one right here, B, does not belong. So all you got to do is convert all of them to moles. Whichever one is not the same, that's going to be your odd one out. All right, on the back, we had a few longer questions. Question 10, percent composition. The first step of percent composition is always to find the molar mass. So that's the first thing we're going to do. We're going to look at all these elements here. Carbon, hydrogen, oxygen. You got 2 carbon, you got 5 hydrogen, and you got 1 oxygen. Remember, if there's no subscript, we count it as 1. And we're going to use our periodic table to figure out how much each weighs. We've looked at each of these elements before, so I'm just going to do it quick. Carbon is 12 grams, hydrogen is 1 gram, oxygen is 16 grams. So I want us to think of our mass contribution. So 2 carbon would weigh a total of 24. That's how much all my carbon weighs here. 1 hydrogen weighs 1, so 5 hydrogen would weigh 5. And 1 oxygen weighs 16. And if I add all these together, my total molecule has a molar mass of 45 grams per mole. So when I want to find my mass composition for each element, all I got to do is I take how much all my carbon weighed and divide it by the total mass. And that's my percent for carbon. So 24 divided by 45 equals 0.533. And I need to turn that into a percent. So remember, when we make a percent, move your decimal spot 2 spots over. So we would say 53.3% carbon. Or if you don't like moving your decimal 2 spots, just multiply this by 100. For hydrogen, all my hydrogen weighed 5, so it would be 5 divided by 45. 0.111, or 11.1% hydrogen. And for oxygen, I had 1 oxygen, it weighed 16. Divide that by the total. 16 over 45 equals 0.35, and we can round it up to a 6. It's about 35.6% oxygen. And the greatest thing about these types of questions is if you add all your percents up, you'll get 100%. Or at least, somewhere between 99 and 101% if we're rounding. This next question, find the percent composition of carbon in the molecule ibuprofen. I'm only asking us to find percent composition of carbon. So you don't got to do every single element here. So again, first step, find our molar mass. We got 13 carbon, 18 hydrogen. This is a big molecule. 2 oxygen. And look, we know how much each one weighs just from that problem above, 12 grams. 13 times 12 is 156. You know, hydrogen just weighs 1 gram, but you got 18, so they weigh a total of 18. And we got 2 oxygen, each weighs 16, so that would be 32. For my total molar mass of 206 grams per mole. So if you got 206 grams of ibuprofen, you got a mole of ibuprofen. So now if I want to find my percent composition of carbon, it is 156, my mass of carbon, divided by 206. 0.757. That would mean it's 75.7% carbon, and that's it. We don't need to get to other two elements because I didn't ask for them. All right, 12 was a tricky one, and I had said you don't want to round any of your numbers. So we'll take a quick look at this. It says an analysis of the pain reliever morphine gave the data, 17.9 grams of carbon. We'll write that down. 17.9 grams carbon, 1.68 grams hydrogen, 4.225 grams oxygen, and we got nitrogen here too, 1.228 grams of nitrogen. So our first step, well, let's see, it says find the empirical formula of a molecule of morphine. So our first step is we got to turn all these to moles. So if you want to turn something into a mole, you have to divide by its molar mass. And we don't want to round these, so we're going to use all the decimals we get here. 12.0107. For carbon, hydrogen, 1.00794. Oxygen, we'll put all these decimals here. 15.9994. And nitrogen, 14.00674. 00674. All right, so we got those there. We're going to divide these, and we're going to keep maybe, I don't know, we've got to keep a lot of decimals here. Maybe we'll keep 5. So for carbon, it'd be 1.4903. Maybe we'll just keep 4 decimals. And that would be moles of carbon. All right, for hydrogen, 1.68 divided by 1.00794. That would give us 1.6668 moles of hydrogen. All right, for oxygen, 4.225 divided by 15.9994. Which would be 0.2641 moles oxygen, and we got nitrogen left. 1.228 divided by 14.00674. And that gives us 0.0877 moles nitrogen. So if all those were whole numbers, done. But they're not. So we got the strategies to get there. Our strategy is going to be divide by the smallest number. And we have to treat them all equal at this point. So find your smallest number and divide all of them by that. And it's going to be this right here, 0.0877. And when you divide a number by itself, you get 1. So you're already there, you got one whole number. Divide all of them by 0.0877. And we'll take a look at what we get. We'll start here with oxygen. 0.2641 divided by 0.877. 3.011, and this is where we're going to round it, that's 3 moles. That's 3 moles of oxygen. We're just 0.01 off. All right, for hydrogen, 1.6668 divided by 0.877, 19.005. Look at that. 19 moles hydrogen. And we got one more. It looks like we're hitting the whole numbers. Cross your fingers for this last one. 1.4903 divided by 0.0877. 16.99. That is basically 17 moles of carbon. So our empirical formula would be carbon 17, hydrogen 19, oxygen 3, and 1 nitrogen. Oops. There we go. So if you rounded your numbers before, it's very easy, especially on these larger numbers, to be a number off. That's why we have to keep all our decimals till the very end. And we got one last question here. Find the molecular formula of a substance with this composition. And because we're finding molecular formula, we have a molar mass there. So jumping right into this, we could turn our percents into grams because remember, you can assume your sample size is any size. So assume it's 100 grams. So percents turn directly into grams. And for this one, you know, we could round a little bit more. All right, so when we divide these ones, we're going to be dividing by molar masses. So exactly like the first step here, except I'm just not going to take as many decimals. So carbon would be like, divide by 12.01, hydrogen 1.01, oxygen 16. And again, that's straight from the periodic table. These numbers here. So when we do that, let's see what we get. 55.8 divided by 12.01. We get about 4.646 moles of carbon. 7.04 divided by 1.01 gives us about 6.97 moles of hydrogen. 37.16 divided by 16 gives us about 2.32 moles oxygen. All right, so we're in a good spot right now. Just got to turn these into whole numbers. So remember, we have to treat them all equal. We got to divide by the smallest number. Something when I was looking at the test, I noticed some students chose not always to divide it by the smallest number, and they still got their correct answer, and that's okay. But if we divide by the smallest number, it's a good strategy, and it makes the math a little bit easier going forward. Because our smallest number will always be 1. That's the smallest whole number. And the other ones are going to be a little bit bigger. So we got 1 mole of oxygen. Let's see how much hydrogen we got. 6.97 divided by 2.32, 3.004. That's 3 moles. Look at this. It's looking real nice here. 3 moles of hydrogen. And for carbon, 4.646 divided by 2.32, 2.002. That's about 2 moles of carbon. That is all whole numbers. If we didn't have all whole numbers, what you would do is you would multiply by the lowest possible number to make them all whole. So we'll write our empirical formula over here. C2H3O. And that's going to help us get to our molecular formula. So if we want to think, how much do all these weigh? We got to find the molar mass here. We have 2 carbon, 3 hydrogen, 1 oxygen. Look at the periodic table to figure out how much they each weigh. and add that up. It's about 43 grams per mole. When we're getting molecular formula, we have to be given molecular mass. And we want to think how many times bigger is our molecule than our empirical formula. So the way we would do that is we would take our 86 here, divide it by our molar mass of our empirical, and we'll notice our molecule is 2 times larger. Whatever number we get here, it should be like a nice number that when we multiply it by our empirical, it'll give us a whole number. So if it's 2 times bigger, what you do is you take your empirical formula, multiply everything by the number you get here. So in this case, times 2. So our molecular formula is C4. H, 3 times 2 is 6. And then 1 times 2 is 2. And that is our molecular formula. Right there. All right, so I'm hoping this was helpful. I'm hoping this was a good practice. We also got the study guide if you need that. But with enough practice on this, we should feel comfortable doing the retake.